Okay, so I'm going to drill a bit into one of these issues, and this is about, so I've got a long title here, but it's a simple message. How do we get data from these kind of models that we were just hearing about that have these unusual structures into ArcGIS? So that's the point of this. And this is an example of one of these kind of grids. This is a data from unstructured grid, basically triangular grid, ocean model, which is used very commonly for inundation and for very high resolution coastal modeling work. This is the kind of information that you need for coastal marine spatial planning in many occasions. In fact, this model is a snapshot from a model, a 30-year hindcast in the Gulf of Maine that was commissioned by the Massachusetts Coastal Zone Management, and it produced a 33 terabyte data set that's sitting remotely on a server. And so, the guy in the office at Coastal Zone Management in Massachusetts is wondering, well, how am I going to use that data? He uses ArcGIS. Okay. So, it's not just Massachusetts that's producing output like that. This is a picture from the U.S. Integrated Ocean Observing System. There's 11 regions around the country that are all running these kinds of models, and they had a need to try to integrate or develop an interoperability strategy so they could also build common tools outside of ARC and inside. Okay, so they approved these different types for different types of data. IUS produced these this little map here where you have the data type here and the web service that's recommended, and then the encoding over here. So I'm going to be talking about this part here, this gridded model output. They recommended OpenDAP or web coverage service if it's a uniform grid, and then delivery of that if you want to store it on disk as NetCDF with these climate and forecast conventions. Okay, so actually here's just a bunch more of these grids giving you an idea of how pervasive these unstructured grids are. These are all inundation grids that were used for hurricane response. And I wanted to point out this grid in addition. This is a curvilinear grid, okay? So it's a structure, a logically rectangular array, but it's got curvilinear coordinates. And I wanted to point out this part too, which is this is the vertical coordinate. It's a fixed number of layers that span the water column that move up and down in time. So to know the z position of some of the data in this array, you have to calculate it from a formula. That's all encoded in that CF convention, but that's a pretty complex data model. Okay, so how do we deal with that stuff? Okay, so there's the CF conventions that were developed in the climate community, now being used in atmospheric and coastal oceanography as well. And so what did IUS come up with? IUS came up with this sort of model where folks create their data in these different structures over here that may be NetCDF, they may be HDF, they may be GRIB, and then they install this a data server that allows them to use XML to add in the different attributes into this data. So they take sort of their own sort of non-standard data, and it becomes standardized through adding these attributes that allow the data to be CF compliant. So it all goes into this sort of common data model. So you might think of this as like GDAL, but with a more complex data model. And then it goes out through a variety of services, and this one, OpenDAP with CF, is actually the only one that can represent all the complexity of those different data models, the kind of models we just showed. And so how do you get it into ARC? Well, before we used something called the Environmental Data Connector, which was a standalone app that you could use to connect to OpenDAP and get the data into ArcGIS. We could use the tools that, I guess, for some of these data that Pat talked about. But now we have a new opportunity because of the strong Python connection in ARC to actually use Python tools to go directly from OpenDAP into ARC, from the OpenDAP service into ARC. Okay, and so in Python, there's actually several options for OpenDAP, but the one that we particularly like is NetCDF for Python because it's built on top of Unidata's C library, which means that as Unidata continues to evolve NetCDF, it can continue to evolve as well. So we're just sort of layering on top of that. So it allows users to open and access OpenDAP just the same way you would open and use a local NetCDF file on your disk. And that's pretty powerful. It can also write NetCDF 3 and NetCDF 4 files, so if you want to actually store your data, the results of your computations, that way you can. Okay, so this is what the data flow looks like from these models where people leave stuff in their own formats through this common data model on the server side, delivered through this service through NetCDF 4 Python into ArcGIS. So how does that actually look then? Well, if you have some, you can actually open up you can import NetCDF4, read in some data, and then you can create shapefiles. That's one way. So this is, polygons and points. But another way, which is we really want to get the data in. We want to get the data with the connectivity in there. We don't really want the shapefiles are good, but what we really want to do is do this kind of thing. We want to open up a data set, and then pull out the piece that we want, and then use something like this. In ArcPy, there's NumPy array to raster. That's great for raster. It goes, now we have the data in Arc, and we can do all sorts of stuff with it there. Okay, but that's for raster data. We already know how to deal with raster data pretty well. What about this other kind of crazy data? So the unstructured grid data, actually, it turns out that one way, it's not the greatest way, so this is a room for improvement, but with the new, so we used the new 10.1 Python toolbox, write a little routine where you import NetCDF4, import ArcPy, use this land XML. So you write out land XML after you've read in your unstructured grid data, create the XML file, and then you use XML to tin to read it back into Arc. Seems kind of wacky, but it works. And so here's actually the data from this grid in Arc as a tin. And of course, so the Coastal Zone Manager can actually look at the data on the original grid, which is really important, right? He hasn't lost any information at this point. But then if he wants to, he can go in and go, he can go tin to raster, right? So this is a zoom in on that same data. This is bottom temperature from a particular month. And you can go to raster. You can see that that when he went to raster, it honored the coastline, which is something that regular interpolation, if you just interpolated from points, it would not do. So this is exactly the kind of product that the Coastal Zone Manager wants. He wants to be able to dip into this data and create the products that are necessary for the particular issues that arise. So it's a sort of a dynamic creation of his own products. He doesn't have to go back to the people who ran the model and request, a special new product every time something comes up. Okay, so, Wish 1, this works great right now because Arc 10.1 uses the same, so NetCDF4 Python is kind of a pain in the butt to build, and it's a binary, right? So it depends on the version of Python, it depends on NumPy. Well, the nthought Python distribution is one of these scientific Python distributions. There's several of them out there that have 100 packages or so that you can do a one-click install on Mac, on PC, on Linux. So if you've got one of those environments, you can really start to be interoperable in the Python world with the rest of your community. And so happens that nthought right now is in lockstep with ArcGIS 10.1, uses the same version of NumPy, uses the same version of Python, and so we can just go ahead and, if you're an Esri user and you've installed the nthought Python distribution and you've installed 10.1, you can start going to town using all that Python functionality, 100 packages at your disposal that just work. So I'd like to see that continuing because I can imagine it breaking the very next release. So one thing that would be nice would be to work with these companies that produce these packages. There's a lot of value to the community there. And maybe it would be something as simple as just saying in advance, and maybe you already do this, what your interface specs are going to be. What versions are you going to be using a significant amount of time in advance so that these other companies can build distributions that work with you. So this, again, there's SciPy, great stuff, PyHDF, there's tons of packages that come with these distributions that you can just start using. And then the two is we've already heard this several times from the previous speakers, supporting these native grid data structures more cleanly in ArcGIS. These are all these time-dependent structures. There is a well-described specification for these in the CF conventions, these different data models, but we can't really, it's sort of awkward to squeeze them into ArcGIS right now. We can squeeze in the tin data, but what about for these meshes that actually have quadrilaterals as well? And what about these curvilinear models with these vertical coordinates going up and down? There's lots of different ways we could do that, so we can talk about that over this week. And finally, we should get rid of silly things like having to write an XML file when we've already got the data in binary in the memory, and we just want to pass it to an Arc structure. We want routines like NumPy to raster to exist for these other data structures as well. So, this is a real win-win. The community, if we really embrace this Python, the Python tools that are out there already and available through these easy to install and use installations, the community wins and Esri wins, I think. The users win because they have access to all these different tools. They can help themselves so they make their own products. And I think probably more scientific customers for Esri. To tell you the truth, I wasn't really, I mostly lived completely outside the Esri world, and started getting a lot more interested when I saw, the Python interface developing. So, thank you.